Our next guest is Peter Burns, the Massman Professor of Civil and Environmental Engineering and Earth Sciences in Notre Dame's College of Engineering. He also directs ND Energy. Peter's been at Notre Dame since 1997 and has focused most of his research in the past decade on the material science of actinides like uranium and plutonium. Welcome to Notre Dame Day, Peter.
Thank you.
Great to have you here. All right, so first question, do I need to be worried about radioactivity on set here, given the elements that you work with on a daily basis?
Well, it really depends on if you're worried about hair loss.
Oh, I am worried about that. That's not something I want quite yet. In all seriousness, do you work in nuclear materials? Well, it's fascinating your work in nuclear materials. Could you explain to us what the end game of your efforts are in this area?
Yeah, so today, 20% of our electricity in the United States comes from nuclear power, and it's a CO2-free, rather clean source of energy. But unfortunately, the system we're using is pretty unsophisticated, and uranium ore is mined and basically fabricated into nuclear fuel that goes into a reactor, but we only recover about 1% of the energy that we could if we took the technologies to the maximum. So most of our work is focused on actinide materials, uranium materials in particular, and ways that we can make much more energy without needing to mine a lot more uranium and create a lot more waste.
Okay, and you're also the director of ND Energy. Can you tell me more about that group?
Sure, ND Energy it's a university center. We have 70 affiliated faculty, a lot of students as well, and our emphasis is primarily on facilitating the research of our faculty and graduate students, building community, and doing things collaboratively on large scientific projects and engineering projects. We have a lot of different emphasis areas that relate to the different themes in energy research on campus. But primarily, first of all, we're a research center, and secondarily, we're a kind of a community builder and also a center that manages outreach and education in all things energy on Notre Dame's campus and also in our community.
Wow, okay, and we've heard you talk about one of the researchers here at Notre Dame working on something called solar paint. Could you explain a little bit more about that and where it stands with respect to being made available to the public?
Sure. Well, right now, most solar panels are made of silicon, and they're relatively inefficient, but they're getting quite inexpensive. But they're still major installations that you have to put up on top of a building and point them at the sun and so on. One of our research groups, run by Professor Prashant Kamat, has developed this solar paint that you can literally paint onto a surface and turn it into a solar electricity generating station. Now, they're nowhere near as efficient as a silicon panel, for example, but the idea is that you could paint all kinds of things that you might not otherwise think of as needing paint. For example, if we added this to all of the highways in the United States, we could turn all of our highways into solar panels. Even with a very low efficiency, we could still generate a tremendous amount of electricity. Now, I don't think the paint is quite ready for sale over at the Home Depot yet. I'm first in line, though, to put it on my house when it's ready.
Yeah, that'd be great. Wow. And of all the things going on in ND Energy, can you tell us what you might think might change the game of renewable energy in the U.S. and around the world, solar, batteries, wind, biofuels, etc.?
There's so many different things going on in our center with 70 different faculty members in their research groups. Some of the potential game changers are in the area of CO2 sequestration and conversion into useful fuels. CO2 sequestration, the concept has been around for a long time. Basically, when you burn a fossil fuel, you could somehow capture the CO2 and perhaps pressurize it and pump it underground or something. That's probably not a great idea. But if you could take that CO2 you've captured out of the flue gas and convert it by some chemical process using perhaps solar energy or wind energy into a useful fuel that you could then burn again instead of fossil fuel, you've basically eliminated CO2 out of the picture because it would be carbon neutral. So that's one potential game changer. Another in the area of batteries. as we think about the electricity grid that we have in the United States, we have a lot of different feeds into it. Solar and wind are some of the cleanest, but they're very intermittent, so we need better batteries that charge faster and release their energy more efficiently so that we can take full advantage of the various energy sources we have.
Wow, a lot of exciting things happening, it sounds like. Yeah. All right, well, thank you very much for joining us on Notre Dame Day.
Well, thank you.